Welcome to the Crazy Hat Chemist. So here we are doing the fourth video in our series of 4. So this is going to be our last video here on this segment here. And if you want to watch further ones, you're going to have to go to my honors chemistry section. So this is my general chemistry section. This is going to be electron configurations and orbital box diagrams, worksheet number 4. Okay. Before you start this video, you need to make sure that you have watched my previous 3 videos before you do that. That is electron configurations and orbital box diagrams, worksheet number 1, 2, and 3. So please watch those first. All right. So we're going to zoom through this here rather quickly here. Before we continue on, we're going to do a summary of our periodic table again so that you know all the different parts. So here is our periodic table that we're going to be using here. So all the different parts are as follows. So this in the pink section, these are S-type orbitals, that's sharp. In the green section, P-type orbitals, that's P-type orbitals. In the blue section, D-type orbitals. In the orange section, F-type orbitals. The principal quantum number or period or horizontal section and energy level is 1, 2, 3, 4, 5, 6, and 7. The D's are 1 less than the period. So this is period 4, then this is a 3D. Period 5, 4D. Period 6, 5D. Period 7, 6D. All right. And then the F's are 2 less than the period or 1 less than the D. So if it's 6 period, the 6th period, and it's 5D, then it would be a 4F. Period 7 would be 6D, and then a 5F. Okay, fantastic. The other thing that we're going to look at here is if we fold this periodic table, what grade do you not want to get in chemistry? An F. So let's get rid of the F's. What other grade do you not want to get in chemistry? That's a D. So let's fold out the D's. Now you can see all the satisfactory passing grades here in chemistry. These are right here, the representative or the main group elements. These are the representative or main group elements. So you'll see that in a textbook somewhere. The S's and the P's follow the periods. So this is actually period 4, and the S's are period 4, and these P's are also period 4. Okay, this is period 5. These are period 5 for the S's, and these are also period 5 for the P's. Okay, the numbers that are written at the top are the number of valence electrons. So that is in the columns, in the vertical columns, which are groups or families. And this is 1 valence electron, 2, 3, 4, 5, 6, 7, and 8, excluding helium. If you open this up here, then you will see that I have drawn out a boot. And so how many boots do you wear? You wear 2 boots. And that's why if you end in a D or an F, so if you're an element in the D or an F region, you can see the outline of a boot. So how many valence electrons would you have? That's right, 2 valence electrons. All right. Fantastic. So what we're going to do is we're going to do some electron configurations and orbital box diagrams of the elements that I just aforementioned. We're going to do nickel, copper, zinc, germanium. And then on the back side, we're going to do selenium, bromine, krypton, rubidium, and strontium. So we're going to do a bunch of elements here, and I'm going to add in one more if I don't forget. All right. So without further ado, let's see if we can nail these down. So our first one here is going to be, let's zoom in on this just a little bit so that we can actually see these here in its complete glory and beauty. All right. Yes, indeed. Okay, so we're going to do element number 28, which is Ni, which is nickel. Okay, if I had a nickel every time someone asked me to do the electron configuration for nickel, that would be fantastic. So what we're going to do is we're going to find nickel on our periodic table. Hopefully you got that joke. Okay, we're going to find nickel on our periodic table, and it is right here. That is element number 28. That's Ni for nickel. All right, perfect. So I'm going to zoom on out so that we can see the full section of the periodic table, which is necessary here for this problem. Zoom in just a little bit. Here we go. Let's see if we can center this. Perfect. All right, looking good. So we're going to do the electron configuration and then orbital box diagram for nickel. So here is nickel. So we're going to go up one floor or one period and slam it to the far right. That will be argon. Argon would be my noble gas that I'm going to use. And then I'm going to do 4s, 1, 2. Then it's 3d, 1, 2, 3, 4, 5, 6, 7, and finally 8. Nickel is most certainly within the boot. That's why there are 2 valence electrons. So I'm going to go over that just one more time. So for nickel, I'm going to go up one period, slam it to the far right. I'm going to have argon. That is element number 18. That's going to be in brackets. That's my noble gas. All the noble gases are here in this far right-hand column highlighted in yellow. Okay, so we've got argon in brackets, then it's 4s, 1, 2, then it's 3d, 1, 2, 3, 4, 5, 6, 7, and 8, and there are 2 valence electrons. So let's write that down and see what we got. So we've got nickel, we've got argon is our noble gas, that's in brackets. We have 4s2 and then 3d8, just like that. We said that there were 2 valence electrons because nickel is in the boot. This is going to be AR for argon. This is a 4s label. This is a 3d label. We have up, we have down, we have 1, 2, 3, 4, 5, 6, 7, and finally 8. Perfect. All right, now we're going to do the next element here. The next element is copper. You're speeding down the highway and who pulls you over? Well, that would be a copper. So that's element number 29, and that is for Cu. So let's see if we can find that on the periodic table. So it's kind of like I'll see you at the movies. Okay. All right, here we go. So copper is the next element. That is element number 29. That's Cu. That's for copper. So let's see if we can write that one down. We're going to go up one period and find our nearest previous noble gas. That is going to be argon. That's going to be in brackets. Then it's going to be a 4s, 1, 2. Then it will be a 3d, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We're going to do that one more time. There are 2 valence electrons. We got copper. We're going to go up one period, slam it to the far right. That's argon in brackets. Then it will be a 4s, 1, 2, 3d, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And there are 2 valence electrons because copper is in the boot. So let's see if we can write this down. That is going to be AR for our noble gas. That's in brackets. That's 4s2, then 3d9. We said there were 2 valence electrons because it's in the boot. That's argon, just like that. This is 4s. This is 3d. This is 1, 2. This is 1, 2, 3, 4, 5, 6, 7, 8, and finally 9. I'm going to mention a couple of things here. Copper has a single unpaired electron, and I just highlighted it. That means that copper is paramagnetic. That means it will be hung up in a magnetic field. It's attracted to a magnet. Okay. I'm going to make one other note here, and that is copper has an electron configuration that is actually something different than this. So if you were to dive into chemistry more than what you are doing right now, you would find out that copper has an actual electron configuration that is different. But what I am discussing in all these 4 worksheets, that's worksheet 1, 2, 3, and finally 4, what I'm discussing are the predicted electron configurations. So that's what we're going to stay with. So if you want to go up into those higher levels of chemistry, then you will find out that the actual electron configuration of copper is different. So something for you to look at in some of my other videos for either honors or AP chemistry. So if you want to go even further in your chemistry learning, I have it for you already online in YouTube videos. By the way, you are watching The Crazy Hat Chemist, a little bit of selfless advertising here. If you're learning stuff here in this, then please like and subscribe. All right, next element is element number 30. That is zinc. That is Zn. Let's find that element, number 30, on our periodic table. And that is right here. That's element number 30. That's Zn for zinc. Okay, this is the last one in the D block of the 3 Ds. So we're going to find zinc. We're going to go up one period or up one floor, slam it to the far right. We're going to get argon. That's element 18. That's a noble gas. That's going to be in brackets. Then it's going to be a 4s1, 2. Then it's a 3d, 1, 2, 3, 4, 5, 6, 7, 8, 9, and finally 10. So again, that's up one period, find your zinc. Up one period, slam it to the far right. That's argon, that's element 18. Then it's 4s, 1, 2, 3d, 1, 2, 3, 4, 5, 6, 7, 8, 9, and finally 10. Let's write that down and do our orbital box diagram as well. Okay, so that's argon in brackets there like that. Then it's a 4s2 and a 3d10. It said that there were 2 valence electrons in this, and those are the 2 valence electrons right there. Okay, this is argon in brackets, and we have a 4s, we have a 3d. Perfect. Those are all labeled. This is up, this is down. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, and finally 10. And since all these electrons are paired, all electrons are paired, this is diamagnetic. So diamagnetic is not attracted to a magnetic field. That's what it is. Okay, the next one that we're going to do is we are going to do element number 32, which is germanium, and that is Ge. Let's see if we can find that on our periodic table. Okay, and here we go. Okay, so number 32, that's Ge, that's for germanium. All right, awesome, fantastic. So what we're going to do, this is in the P block. So we're going to go up one period and we're going to slam it to the far right. That's going to be argon. So after argon, then we're going to do 4s, 1, 2. Then it's 3d, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then there's this break here between the d's and the p's. Okay. And if we fold this periodic table back again, we will notice that the s's and the p's stay with the period. So it's going to be a 4p12. Okay, so we'll just go over that here real quickly again. I know that was pretty quick, but we'll do it real quickly again. That's germanium. We're going to go up one, slam it to the far right. That's argon. Then it's 4s, 1, 2, 3d, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then it is 4p12. All right, so let's write all that down so that we get all that information written down here for germanium. That's argon in brackets. That's a 4s2, 3d10, and 4p2. So that's AR. That's a 4s, this is a 3d, and this is a 4p. Okay, this is an up, this is a down, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and then finally up and up. Okay, this here is following Hund's rule. Hund's rule is maximum multiplicity, that's maximum number of unpaired electrons. We're going to add one more thing here that we didn't add before. That's the number of valence electrons. It's the largest principal quantum number. That's the 4s. We're going to sum those two numbers up. That's the 4s. We're going to sum 2 plus 2. That's 4. Let's double check that. Germanium has a 4 on top. That's 4 valence electrons. I want to mention one other thing now that we are here, and which I haven't mentioned before. You notice that the S-type orbitals have a single box. The P-type orbitals always have 3 boxes, no matter if you fill them in completely or not. The D-type orbitals always have 5 boxes. And these are very special numbers, and I'll write this down. 1, 3, 5. What would be the next number in this series? That would be a 7. That's right, folks. That would be a 7. So we have S, P, D. The Fs have 7 boxes. That's right. Okay, so we've just finished the front side. Now we're going to do the back side of this worksheet. So let's flip this over and do the back side of this worksheet. And we have a few more problems here to do. And here we go. At the top is selenium. Okay, so selenium is element number 34. That's Se for selenium. Let's find selenium on our periodic table. That is right here, number 34, Se for selenium here. Sorry, I had the key right over it, but you can clearly see it, hopefully on your periodic table that you are using at home. Okay. All right, so here we go for selenium. There is selenium number 34. We're going to go up one period, slam it to the far right. That is argon. Then it is a 4s, 3d, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then it is a 4p, 1, 2, 3, 4. Perfect. That will be it. And we're going to write that down. That's argon, 4s, 3d, 10, 4p, 1, 2, 3, 4. How many valence electrons? 6. So let's write this down here. That is going to be argon in brackets. That's a 4s2, 3d10, 4p, and that was a 4. And then we had 6 valence electrons. That's 6 right there like that. You can see the valence electrons, the largest principal quantum number is a 4. We're going to sum up the 2 and the 4. We're going to write our orbital box diagram of the same element. That is argon in brackets. That's our noble gas. This is a 4s. This is a 3d. This is a 4p. And we have an up, we have a down. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and finally 10. And then we have 1, 2, 3, and finally 4. Perfect. That's selenium. All right, let's see now if we can do our next element here. Our next element is the next element in line, and that is number 35. That is bromine, and that's for BR. No way, bro. Sorry, very bad joke. Okay, all right, so let's see if we can find bromine. That's a BR, that's bromine, that's element number 35. Hopefully you're getting this pattern. That's why we're trying to move fast. We got bromine. We're going to go up one period, slam it to the far right. That's argon in brackets. Then it is a 4s, Then it is a 3d, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then it is a 4p, 1, 2, 3, 4, 5. Perfect. Write it down. Valence electrons, 7. All right. I don't need to do that twice, hopefully. That is argon in brackets. That's a 4s2, 3d10, 4p5. That's 7 valence electrons, and that's argon. That's a 4s type of orbital, 3d type of orbital, and a 4p type of orbital. That's an up, that's a down. That's 1, 2, 3, 4, and 5, 6, 7, 8, 9, and finally 10. That's 1, 2, 3, 4, and 5. This is also paramagnetic because it has 1 unpaired electron. It's right there. I'm going to scroll this on up so that we can see some of the other ones that we have before us. The next one is going to be element number 36, and that's krypton, that's Kr. No, that is not kryptonite. That is completely different. I don't even know what that stuff is. All right, so here we go. We're going to find krypton. That is actually the noble gas of krypton. So what we're going to have to do right now is we're going to have to go up one period, slam it to the far right. And wait, we already slammed it to the far right. So we're going to write argon. Then it is a 4s, 3d, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then a 4p, 1, 2, 3, 4, 5, and 6. How many valence electrons? 8. Let's do that one more time. We're at a noble gas of krypton. We're going to go up one period. That's argon. That's in brackets. Then it's 4s, 2. Then it's 3d10. Then it's 4p6. Let's write that down. All right, so that's argon in brackets. That's 4s2, 3d10, and a 4p6. And we have 8 valence electrons. We can sum up those two numbers there. That's argon. That's a 4s. That's a 3d, and this is a 4p. This is up and down and up, 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 up. That's 5, 6, 7, 8, 9, and 10. This is 1, 2, 3, 4, 5, and 6. And krypton is diamagnetic. That's right. Perfect, because it has no unpaired electrons. It would rather die than be attracted to a magnetic field. All right, we're going to scroll this on up here, and so that we can see our very last 2 problems. Okay, our last 2 problems. By the way, you are watching the one and only, the Crazy Hat Chemist. That's right, folks. The one and only Crazy Hat Chemist. That's me. The next element that we're going to do is element number 37. That's rubidium for RB right here. And place that right here like this. Place that down there like that. And we're going to find rubidium. That's number 37. And that's RB, rubidium. So this one will be easy here. We're going to go up one and slam it to the far right. So in order to do that, what I'm going to do is I'm going to just real easy. Let's fold this over so that we can really focus on what's of interest here, truly. Okay, so there's rubidium. We're going to go up one floor, slam it to the far right. That's going to be krypton. That's 36. We only need to do one more after that, and that's going to be a 5 and an S and a 1. Krypton in brackets, 5s1. Okay. Krypton in brackets, 5s1. Krypton in brackets, 5s, and that's a 1. And valence electrons, that's also very easy here. Rubidium is right here. What's the column? Number 1. It's in group 1. So how many valence electrons? 1 for rubidium. All right, we're going to do one more here. We might have an extended version of this here in just a moment here. We're going to do a couple more elements here maybe. All right. So the next one is element number 38. That is strontium. That's for SR. Bonus ones here. So strontium, we're going to find that element here. That is element number 38. That's SR. That's strontium. And so what we're going to do is we're going to go up one period, slam it to the far right. That's krypton. Then it's a 5 and an S and a 1, 2. Again, strontium, up one period, slam it to the far right. That's krypton. Then it's 5s, 1, 2. Boom. Let's write that down. So that's krypton. And then 5s2. That's krypton. And that's 5s, 1, 2. And number of valence electrons for strontium, it's in group 2. So 2 valence electrons. Okay. We're going to do a bonus question right here, folks, and that is hydrogen. Let's see. I'm going to write this in a different color just so that you don't get mixed up here. Hydrogen. That is element number 1. Okay. So hydrogen is right here. That's element number 1. And so we're going to do the electron configuration and orbital box diagram of that. So hydrogen is 1s1. 1s1. That is the electron configuration for hydrogen. If I want to do the orbital box diagram for hydrogen, it would be a single box. It would be labeled 1s, and then it would be an electron up like that. Then we're going to do one more here, and that's helium. And that's He, and that's element number 2. So let's do that one here real quick. There is helium, that's element number 2, and that is going to be a 1s1, 2. 1s2, and its orbital box diagram. 1s is an up and a down. That's it. That's it for helium. So just a real quick little recap and summary. I'm going to highlight here some elements that are on our periodic table, and I'm going to zoom on out so that we get our entire periodic table here. With the summary of all 4 videos, I have done all the elements 1 through 38, their electron configuration and their orbital box diagram. So I have done the electron configuration and orbital box diagram for all the highlighted elements right up here, 1 through 38. So if you watch all those videos, you'll get all of them for 1 through 38. Here's a quick summary of today's worksheet, and that would be the following. This is the front. This gets you all of it on the front. Let's zoom on out so that you can get all of it. And there it is. I know it's rather small, but still it's all there. This is the backside. So this is nickel, copper, zinc, germanium, and this is the backhand side. And this is selenium all the way up to strontium. And zooming on out for that one just a little bit more. There we go. Okay. I hope this was very informative and hopefully you learned something. Of course, I am the Crazy Hat Chemist, and I hope you have a good morning, a good afternoon, and a good evening. And I will see you next time. Please like and subscribe, and thank you very much. Appreciate it. Bye for now.